Alright guys, today we are going to be doing the last lesson in kind of our simplifying unit. So we've done simplifying expressions part 1, and then we went over the distributive property. And this simplifying expressions part 2 is kind of putting what you learned in the first one and the distributive property together. So if we're looking at our notes, this part right here should look very, very familiar to your part 1 notes. So what I want you to do right now is pause the video, and I want you to get out your part 1 notes, which should look something like this, and then I want you to use these to fill in this part on part 2. All right, now this part should look a little bit familiar because this is kind of what we did in part 1. And the reason I'm doing this again is because it seems we need a little bit more practice. So if we remember, terms are every part of an expression that is separated by an addition or subtraction operation. So if we look at this expression, 5w and 2 are separated by addition, 2 and w are separated by addition, and w and 5 are separated by addition. So all of those are terms. So we're going to write them all down. Now, coefficients are the numbers in front of a variable. So 5, and remember there's an invisible 1 in front of the w. So our two coefficients are 5 and 1. Now, constants are numbers by themselves. No variable, right? No letter. So it looks like we only have 2 and 5. Now, we do have some like terms. And remember, like terms have the same variable or their constants. So in this expression, we have 5w and w. Those are like terms because they have the same variable. Now, 2 and 5 are also like terms because they are constants. So, what we need to do now is we need to take our pairs of like terms, or you could think of it like things in the same family. Like these are in the W family, these are in the number family. I need to take those things and put them together to write a final expression. So I'm going to do 5w plus w, which gives me 6w. And then I'm going to do 2 plus 5, which gives me 7. All right, let's do another one. We have 2m plus 7 plus 9m minus 4. So first thing first, again, we need to look for all our terms. And anything separated by addition or subtraction is a term. So we have 2m and 7 because they're separated by addition. We have 7 and 9m. They're also separated by addition. And then 9m and 4. And those are separated by subtraction. Okay, now we're going to do our coefficients. And remember, coefficients are the numbers right in front of a variable. They're smushed together like a sandwich. So it looks like 2m and 9m. Those have coefficients. So 2 and 9 are my coefficients. And then remember, constants are numbers that are by themselves. So it looks like I have 7 and 4. All right, like terms have the same variable, right? They're in the same family, or they are constants. So if I look, I know I already have a set of constants, which is 7 and 4. So I already know I have one pair of like terms. Now my other pair of like terms are 2m and 9m because they both have the m variable. They're in the m family. Okay, so now remember, I need to take my like terms and follow the operations to make a simplified expression. So I need to do 7 minus 4, which gives me 3. And now I need to do 2m plus 9m. So I have plus 11m. All right, let's do another one. Okay, terms, again, separated by an operation sign. So we have 2x, 3, and 7y. All right, coefficients are the numbers in front of a variable. And it looks like I have 2 and 7 because 2 is being times by the x and 7 by the y. Constants are numbered by themselves. Looks like I only have 3. Now, if I'm looking at this expression, I need to find constants or numbers in the same, or variables that have the same, or I'm so sorry, terms that have the same variable. But it looks like I have 2x, but I don't have any other x's. And I have a 7y, but I don't have any other y's. And I don't have any other constants to combine 3 with. So 2x plus 3 plus 7y is as far as this expression can be simplified. So we just rewrite it. We don't have to do anything else. Okay. Terms separated by operations, and it looks like I have addition for this one. So 10n and 8 are separated by addition. 8 and n are separated by addition, and n and 6. Now remember, coefficients are the number in front of the variable, and it looks like I have a 10, and remember there's an invisible 1 in front of this 9. So really I have 10 and 1. Constants are numbers that are by themselves, right? There's not any variable attached. So it looks like I have 8 and 6. Okay, so for my pairs of like terms, I already know that 8 and 6 are a pair because constants or numbers can be put together. And then I know 10n and 1n are also like terms because they're in the same family, right? They're in the n family. They have the same variable. So now I have to follow the operation that's in the expression to simplify. So I need to do 10n plus 1n, which gives me 11n. And then I need to do 8 plus 6, which gives me plus 14. So this should be a little bit of a refresher from part 1. Okay, let's do a word problem to kind of get our brain going. It costs X for a ticket and $12 for popcorn. Ooh, popcorn and a drink. There are 6 friends going. Okay, so important information. X is for a ticket, $12 for popcorn and drink, and we know that 6 friends are going to the movies. But it looks like 3 friends get the combo. So we need to write and simplify an expression that represents the total cost. Okay, first question. It says, how many friends are going? Okay, well, if I look back in my text, 6 friends are going. 6. What did each friend pay? Okay, well, I know that 6 friends altogether, but remember 3 of them got a ticket and the combo. So 3 friends bought a ticket plus the combo, while the other 3 just bought a ticket. Okay, so how could we write this as an expression, right? So if I know I'm going to have 6 friends going, and 3 of them bought a ticket, plus the other 3 friends got a ticket, and they paid $12 for the combo. So I need to simplify this. And remember, we learned in the distributive property that you share what's on the outside and you multiply it by all things on the inside. So I'm going to multiply 3 by x, multiply 3 by x, and multiply 3 by 12. So when I do that, I will then get 3x plus 3x plus 36. And now I can combine like terms. And I know that 3x and 3x have the same variable. So I can add them together. So 3x plus 3x gives me 6x plus 36. And in your head, you want to make sure that your answer makes sense, right? So if I'm looking back, this says 6 tickets. Okay, so if I go back into my reading, it costs X for a ticket. 6 friends are going. Okay, well that makes sense because 6 people would need to buy tickets. And 3 friends get the combo. If 3 friends are buying $12, 3 times 12 is 36. So your simplified expression is 6x plus 36. All right, flip on over to the next page. So we're going to practice some more with parentheses, right? So we learned the distributive property. And so this tells us, step 1, we need to use the distributive property to remove the parentheses. Everything else in the equation stays the same. And what this means at this step is that you're going to need to rewrite. You're going to need to rewrite your expression after you remove the parentheses. Okay, and then step 2, just like usual, we are going to combine, combine like terms. And if you don't remember what that means, that's stuff that has the same variable or constants or numbers without a variable. Okay, so let's do some practice. So step 1, to get rid of the parentheses, we have to use the distributive property. We're going to rewrite our expression. Then we're going to combine like terms to get a simplified expression, and that's going to be our answer. Okay, so if I'm looking at this expression here, we have 3y plus 4 times 2s plus 6y. So step 1, step 1, we need to get rid of the parentheses. So if you, just a heads up, if you are working out these problems and your answer has parentheses, you cannot have something simplified all the way down and still have parentheses. So parentheses and simplified is a no-no, okay? So we need to share 4 to all things inside the parentheses. And to share, we multiply. So really, to do that, we're going to do 4 times 2s and 4 times 6y. Okay, 4 times 2s gives me 8s, and 4 times 6y gives me 24y. Okay, now I need to rewrite. So I have 3y plus 8s plus 24y. All right, now I can combine like terms. So I'm going to look for things that have the same variable. And it looks like I have 3y and 24y. And I'm going to follow the operation sign in front. So I'm going to do 3 plus 24. So I'm going to get 27y. And 8s doesn't have anything to combine with, so that just comes down. So your simplified expression now is 27y plus 8s. Okay, let's do another one. Okay, we need to share 4 to both things, all the terms inside the parenthesis. And sharing means multiplying. So we're going to do 4 times q, and we're going to do 4 times 8p. Okay, 4 times q is 4q. And 4 times 8p is 32p. Now remember in the steps, it says that the rest, everything else stays the same. So that p over here just stays the same. So when I rewrite it, I just add it to the end. So I'm going to have 4q plus 32p, and then this stays the same, so I'm going to bring it down. So I have plus p. Okay, now I'm going to look for either constants or things with the same variable. And it looks like I have 32p plus 1. So 32p plus 1p gives me 33p. And I drop down 4q because it doesn't have anything to combine with. Alright, this is when I want you to pause the video. And I want you to try to do these 3 right here by yourself, and then check back in when you are done. Now listen, I understand if something's difficult and you don't want to try it by yourself, but trying by yourself is what helps your brain grow. So I really want you to be honest and pause the video, do these yourselves, and then check the answer when you're done. All right, so by now you should have the 3 practice problems done on your own. So, first thing you should have done is gotten rid of the parentheses. So we need to share 4 to both terms inside. So we're going to rewrite. We have 8n plus, and then we have 4 times 9, which gave us 36. And then 4 times 4n, which gave us 16n. And then you would have found similar things, right? And so you would have said, okay, 8n and 16n have the same variable. So I'm going to do 8n plus 16n, which gives me 24n. I bring down 36 because it has nothing to combine with. It doesn't have a like term. Now, don't make the mistake of combining 24 plus 36, because remember, we cannot combine these because they are not like terms. They do not have the same variable, right? So this is your answer. This is the most simplified this expression can get. Okay, over here, you should have drawn your arrows and shared 6 to both things inside the parenthesis, which should have given you 6x plus 24. Now remember, the rest of my equation stays the same, so I just drop it down. Plus 5x plus 7. Okay, then I would have looked for like terms, and it looks like I have a 6x plus a 5x, and it looks like I have a 24 plus a 7. Okay, so I would have done 6x plus 5x, which gives me 11x. And I would have done 24 plus 7, which gives me plus 31. And 11x and 31 cannot be combined because they don't have the same variable, so this is your answer. All right, it looks like you don't have to distribute any here. You just needed to find like terms. And it looks like I have a y and a 3y. And 1y plus 3y gives you 4y. And I drop down to x. So your answer is 4y plus 2x. Okay. Now, this part is also going to look very similar from your simplifying expressions part 1. Because if we flip to the back, look, we did this on this one too. So, for your important reminder, simplest form has no parentheses. It cannot have any parentheses or like terms. Right? Your final answer should have no groups of like terms or parentheses. And in your own words, I want you to explain how you know a problem is completely simplified. So for example, like, how did you know that 11x plus 31 was completely simplified? So in your own words, I want you to write it down and then check with me. All right. So over here we have some more practice. So it looks like you have 6 practice problems, just like the ones above. So right now I want you to pause the video and I want you to do these by yourself. And then I want you to check back in with me. You can either raise your hand and check in with me, or at the end I will go over the answers. All right, so by now you should have checked in with me. And for the first one, you have 5n plus 2 plus n plus 6. I'm going to combine things that are similar. So I'm going to do 5n plus n, which gives me 6n, and 2 plus 6, which gives me 8. 6n plus 8 is your final answer. All right, for this one, you needed to have distributed to all terms before simplifying. So you should have written 6y plus 3x plus 6y. Now you can combine like terms. So you should have done 6y plus 6y and gotten 12y plus 3x. If you got that answer, give yourself a pat on the back. Good job. Okay, you should have distributed first your 4 to all terms. And 4 times 3q is 12q. My sign stays the same. 4 times p is 4p. And I bring down plus p. Okay, I combine things that are the same. So I'm going to do 4p plus p, which gives me 5p. So I have 12q plus 5p. And that is your simplified expression. All right. You should have distributed 7 to all terms inside the parenthesis. So I now have 25 plus 7x. And remember, the sign in the operation sign in the parentheses stays the same. So minus 14. I combine things that are similar, which is 25 minus 14. And 25 minus 14 gives me 11. And I drop down 7x. So your final answer should have been 11 plus 7x. Now, if you wrote 7x plus 11, that is also correct, right? Because remember, we learn about the commutative property. So it doesn't matter in what order we write it for addition, we're going to get the same answer. All right, for this one here, remember, we need to get rid of the parentheses first before we can combine like terms. So you needed to share 3 to m and 2n. And then you needed to share 5 to m and n. So let's rewrite our expression now. 3 times n is 3m. Operation sign stays the same. 3 times 2n is 6n. 5 times m is 5m. Operation stays the same. And 5 times n is 5n. Now you can go through and find stuff that is similar. So I see that 3m and 5m are similar. And I see that 6n and 5n are similar. So now I'm going to combine those like terms. 3m plus 5m gives me 8m. And 6n plus 5n gives me 11n. Now, we cannot combine 8m and 11n because they do not have the same variable. So this is your final answer. All right, last one. You needed to have shared 6 to both terms inside the parenthesis. So 6 times 2x is 12x. Operation sign stays the same. 6 times 3y gives me 18y, and I bring down plus 15. Okay, so now I'm looking. I got 12x. Doesn't look like I have any other x's. I have 18y. Doesn't look like I have any y's. 15, no other constants. So this is your simplified expression. All right, flip to the last. Oh, no, we got 2 more pages. Okay, Lisa is working on the following problems. Find her mistakes, correct it, and justify your answer. Okay, so what we need to do first is we need to rewrite the equation. We need to write the right equation down. Okay, so we have 8 times 2x plus 3y. Oh, plus 4y. All right, so we need to write the expression down, and then we're going to solve. So let's solve it on our own first. So we need to distribute 8 to all the terms inside. So 8 times 2x is 16x. Operation stays the same. 8 times 3y is 24y. And I bring down my 4y. Okay, well now I can see that 24y and 4y are like terms. So I'm going to add them together. So now I have 16x plus 28y. Okay, so at this time, we need to see what Lisa did that we didn't do. So it looks like she's got the same equation. We have 16x plus 24y plus 4y. Lisa had 16x plus 3y plus 4y. What do you think she did wrong? I want you to take a second and look and try to figure it out yourself. So if you said that Lisa's mistake is that she did not distribute 8 to all terms inside the parentheses, you would be correct. So Lisa, she did not distribute 8 to all terms in the parentheses, right? And we know that the correct answer is 16x plus 28y. And how do we know this? Because we followed the distributive property correctly, and then combined like terms. So, yeah, I don't like that O there. Okay, so to recap, Lisa's mistake is over here. See how she shared 8 to 2x, but she didn't share 8 to 3y. So Lisa's mistake is she did not distribute 8 to all the terms inside the parenthesis. We know that our answer is correct because we did share 8 to all terms inside the parenthesis and then combined like terms. Alrighty, looks like we have some more practice. I want you to do these on your own, and then check back in with me. So I'm going to put in the video, check with Miss Maddie. So I want you to do 10, 11, 12, and then this should be 13, 14, 15, 16, 17, 18. I want you to try to do these 9 problems by yourself, which you should be able to do now, because this is kind of recap from our past lessons, and then check back in with me. Now, if your classmates at your group are also done, you guys can work together on these, and if you guys want to check each other's answers, you can. So pause the video now, do these by yourself or with your group, and then check back in with me. And we have one more page left to go after that. Okay, so for our last page in this lesson, we need to find out now if expressions are equivalent. And remember, when we see this word equivalent, that's a fancy way of saying equal, right? Like, are these expressions equal? So if you want to find if something's equal, you would have to solve it first, right? So what we're going to do is equal, we need to think of equal sign. So we are going to have to set this up with an equal sign in between. Okay? So first things first, we have 5x plus 10. Okay? And then for problem 2, we have 5 times x plus 2. Now remember, we need to get rid of parentheses first to be able to really see the expression simplified all the way. So 5 times x is 5x, operation stays the same, and 5 times 2 is 10. So what I want you to do now is write problem 1, which is 5x plus 10, and then write your equal sign, and then write problem number 2, which we also got 5x plus 10. Okay, so now we need to think, 5x plus 10, is that equal to 5x plus 10? And we would say, yes, those expressions are equal. Okay, looks like we have some parentheses again, so we need to get rid of those first before we can compare, right? So our expressions have to be in simplest form first before we can compare them. So we have 2 times 4, which is 8, and then 2 times 7b, which is 14b. Okay. In problem 1, it looks like we can put 7 plus 1 together, which gives us 8, and we can do 10b plus 6b, which gives us 16b. And now we can set up our 2 expressions now that they're simplified together. So problem 1 is 8 plus 16b equals, remember because we're comparing, problem number 2 is 8 plus 14b. Okay, so now I'm going to look at my 2 problems. I have 8 plus 16b equals 8 plus 14b. Are those equal? No, they're not equal. The constants are equal, but our b variables, they're not equal. Okie dokie, let's do the next one. So, problem 1, we're going to have to combine some like terms first, right? So we can do x plus 9x, which gives us 10x, plus 8 more, which is going to give us 18x. And then it looks like we can do 3 plus 3, which gives us 6. Okay. For problem number 2, we're going to have to distribute first before we can combine like terms. So 3 times 5x gives us 15x. Operation stays the same. 3 times 1 is 3, and I bring down the rest of my equation. Okay, so now I see I can do 15x plus 3x, which gives me 18x, and then I could do 3 plus 3, which gives me 6. Okay, now I can take my simplified expression of problem 1 and 2, and I can put them equal to each other. So I have 18x plus 6 equals 18x plus 6. Are those expressions equal? Yes. They're equivalent, right? They're equal to one another. 18x plus 6 is equal to 18x plus 6. All right now I want you to pause the video, because remember, in math, learning is by doing yourself. So I want you to try the 3 on the bottom and then check back in with me for your final answer. All right, so by now you should have had the 3 practice problems on the bottom done by yourself. So for problem number 1, your answer is no. So when you combine like terms for problem 1, you get 4y plus 13x. And when you distribute for problem number 2, you get 4y plus 52x. And 4y plus 13x is not equal to 4y plus 52x. Okay, so for the next one, when you combine like terms on problem number 1, you get 8 plus 14g. And when you distribute on the second problem, you get 8 plus 14g. So 8 plus 14g is equal to 8 plus 14g. Now, if you had 8 plus 14g equals 14g plus 8, remember, those are still equivalent. They mean the same, even if they're written in a different order, right? Because we could have 5 plus 1 equaling 6, but that's still the same as 1 plus 5 equaling 6. So just because they're not in the same order for addition doesn't mean they're not equivalent. Okay, for the last one, you can't really combine any like terms for problem number 1, so it's already simplified. For problem number 2, you needed to distribute, and now you have 6x plus 4y equals 6f plus 4a. Now, these do have the same coefficients, but they do not have the same variable. None of those are in the same letter family. So they are not equivalent because x and y are not the same and f and a are not the same. Okay, at this time, I want you to raise your hand and I will come check your notes, and then I will give you a practice page to do. When you're finished with your practice page, you can check in with me again and I will give you your homework.